Hi everyone. Hi Elena. Hi Emeli.
Hello, everyone. Hi
Um,
there.
yeah, I'm glad to welcome you today. Uh, yeah. So I'm glad to welcome you today to our webinar where Elena and Emily, co-founders of Evidently AI, will share expertise about AI system evaluation. So Elena, Emily, it's so cool to see you here today. Thank you for coming.
Likewise, we're happy to be here today. Thank you, everyone, for joining us. That's lovely. Yes, thank you for having us. Please let us know when we should start.
Yeah, I think we can probably already start. So
Okay. Then, without further ado, I can take the lead here.
yes, please.
Uh, So once again, thank you everyone for joining the webinar. My name is Elena. I'm CEO and co-founder of Evidently AI. We also have here Emily, who is the CTO and co-founder. And we're going to split the presentation between both of us. So first, I'm going to share a little bit of theory on LLM evaluations and testing, and then we're going to go to practice and actually see how you can apply it on a, well, quite a real example with code and see how this can work. So I hope you will enjoy the session. So the way we're planning to structure it is that first I'm going to give the presentation, then we're going to have the demo, and then we're going to have the questions at the end. But Stanislav, if you think that it should be otherwise, let us know. Okay, sounds good. Perfect. So now let me start with the presentation side. Please confirm that you see the screen. Awesome.
Yeah, we do.
We do.
Awesome. So now let's dive in. So what we're going to talk about today is a few things around LLM evaluations. So first, I'm going to talk about LLM evaluations and testing and the general idea of what it is, how it works, when you need this. Specifically, we're going to talk a little bit more about LLM as a judge, which is one of the most popular LLM evaluation methods, but also one of the most controversial ones. So I hope you will enjoy it. And then we're going to talk about a few peculiarities, like how you can combine the manual and automated evaluations, how you're going to evaluate more complex systems like AI agents, and generally some tips and learnings. That will be my part, and then we're going to go to the demo side, which will be given by Emily. So a little bit of introduction to give us some credibility to talk about evals. So we're working on a company called Evidently AI. And what we do at Evidently, we develop an open source library, well, called Evidently, which is quite popular. It has more than 30 million downloads, and it's used by data scientists, machine learning engineers, and AI engineers across different companies to help them test and evaluate the systems that they built with artificial intelligence. And here we talk about, well, even classic machine learning models like predictive models, and also, of course, the LLM-based solutions that are all the rage these days. And on top of Evidently Cloud, we also have a commercial product, which is on top of Evidently, we have Evidently Cloud, which is the commercial product, which is a collaborative platform where you can set your evaluation data sets, store the results of your evaluations, monitor them over time, and so on, and collaborate with the team. So we've been working on this for a few years, and before that, we have been working on a lot of applied systems in production. So it all is built on the experience of seeing how things can be right and also wrong when it comes to production deployment of such complex and non-deterministic applications. So now let's talk about LLM evals. If you have been following the topic and you're general thinking about building AI agents, LLM applications, AI systems, you know that evals are all the rage, and it's actually probably one of the most popular topics on content marketing these days. I think it's probably not because we care that much about evaluations per se, but because we care about the quality of the systems we are building, and evaluations is, well, how we measure, manage, and improve that. And if you think about evaluations, there are two different ways how you typically approach it, and two different complementary topics. The first thing is if you look for LLM evals, you'll probably find a lot of benchmarks and discussions about how different LLMs perform on these benchmarks. So for example, yesterday, OpenAI released open source or open weights to be precise models. And when they released them, they had to somehow communicate their quality. So they showed how these models perform on different benchmarks. And this is one way how you can, of course, compare if the new model is good or better than the other and so on. And it's important for us to understand the progress and to compare different models between each other. But if you're building a system, you probably care about something a little bit more precise and related to the use case that you're working on. For example, if you look at one of the most popular MMOU benchmarks, which is always reported for any kind of model release, this is the type of questions that you get there, right? So this is more of a general knowledge type of questions on societal, historical topics, and so on, and it's even a multiple choice exam. So of course, it's great when the models are getting these things right, but if you are building, for example, a chatbot or an AI agent that is doing booking or e-commerce support, you probably don't care if your LLM knows what a monopoly is, right? You care if it actually performs on the task that it is meant to solve for your product. And of course, probably if you're dialing into this webinar, you're thinking about specific products. But just to give an idea, you might be building chatbots, right? Support chatbots, internal knowledge assistants, any kind of agentic based chatbots that can also perform certain actions. That is probably one of the more popular applications these days. Also, all sorts of questions answer systems like UEFA files built by Dropbox or different types of summarizations or information extraction tools. These are the type of systems that we're actually seeing in the wild. And if you were to evaluate any of these systems that you're building or any kind of idea that you have for your product, maybe like a specific AI agent, you actually need to evaluate this whole product. And this is the second type of evaluations that we're going to talk about today, mostly is how you evaluate LLM-powered system, not the model that you're using inside the system, but the complete product that you built. And in this case, at the very least, you have a prompt, which is the system prompt that you wrote that basically instructs the LLM to act in a certain way, but it might get much more complicated. You can connect different tools, data sources, add guardrails, maybe use different models for different calls and so on. So you actually need to evaluate this complete thing on the task that it is meant to solve rather than just in general evaluate if the model is good enough. And LLM evaluations are not easy. So if you think about all these tasks and you've previously done a bunch of machine learning, I must say there's quite a leap. So in case of machine learning tasks, we typically solve very constrained problems, like you're classifying something and there is one exact answer, like is it a cat or a dog on an image? And with LLMs, imagine that you're like writing an email or a blog post. There are many ways to be correct. There is not just one precise answer that will be approved and everything else is wrong. No, there are more nuanced type of relations that you might deal with. And also, you're often dealing with some sort of interaction chains. So it's not just one single answer that is generated based on the input you get, but rather you get a session where your user is interacting with your agent, or maybe your agent is performing autonomous tasks, which is like a sequence of different steps. So it's actually quite a lot of things that can go wrong. And because the outputs are open-ended, well, there are also more risks because LLM cannot just predict the wrong thing, but it can also just generate something harmful or biased and so on. But at the same time, when you're talking about evaluating LLMs, there are good things too. So one of them is that we're typically dealing with text, maybe sometimes images, but in general, that is something that you as a human can actually evaluate if you go look at it and read it. And that's actually great because if you can evaluate it as a human, there are also ways how you can automate it, also using LLMs. And we're going to talk about it today. So it's actually quite fun, maybe a bit recursive at first, but a great idea of using LLMs for evaluation of LLM outputs to scale your human judgments. So now let's going to talk about how exactly you can evaluate this LLM-powered system. And one point I want to make is that when we talk about evaluations, we're actually not talking about one single activity. Evaluation is a task that you're solving within different workflows as you build and iterate on your product, and later as it goes into production and you need to maintain its quality. The first step where you usually start thinking about evaluations is what we used to call machine learning experiment management, but basically when you're comparing different setups, designing your product, and you need to actually understand if it's getting better or worse. So for example, you might be trying out different models, like should I use an open source model or should I use this or that provider? Maybe there are different costs. Or maybe you're writing different prompts and you're trying to formulate the same task using different words. So you can actually compare if you're solving the task better or not, right? So that's where you need evaluations at first to basically understand if you're improving or not. Another way when you need evaluations is related to adversarial and stress testing. That is probably not the first thing that comes to your mind if you're just like building a prototype, but if you're building a real system that will be deployed in front of external users, so any kind of public-facing system, or you're working for a large organization, typically this kind of stress testing is very important because many things can go wrong. And sometimes even if it's probably not very popular use case, you don't expect all your users to come and break your system or push it to the limits. Some can do, right? And you don't want to actually be exposed to it when the users try it first. So you want to actually try to break the system before users do to see how it holds against the adversarial prompts. And there are already quite a few examples of things going wrong in real systems. So here is a very fun use case. So a Chevrolet chatbot, which is a customer support chatbot on the website, actually agreed to sell a car for $1 after a user prompted it to do so. And this type of vulnerability is generally called prompt injection. So basically when the user overrides the system instruction by injecting their own instruction into the prompt, because in the end, when you send the things to the LLM, you join this together, right? So there is no easy way to distinguish between the system instruction and the user input, and the user input can be perceived as an instruction. So something like this can really happen for your system. Of course, this is more of like a fun example, but you can imagine many malicious actions that can be generated this way. Or another thing that concerns many large brands, like for example, here is a DPD chatbot example where a disgruntled user also basically went to the chatbot and made the chatbot sing a song or say bad things about the company. And of course, the chatbot complied because again, LLMs are following user instructions. And if the user instructs it to do so, in many cases, they will do something that you as a brand owner don't want to. And one last thing I wanted to share here, of course, there is like many more potential issues, is that because LLMs are non-deterministic, you can actually get different outputs for even for the same input, but sometimes for very similarly worded inputs. So you actually need to test also system robustness in a way that when you ask different questions in a different ways, if it's something important, you need to make sure that the LLM outputs actually coherent. They don't diverge between answers given to different users. They don't contradict each other. Now, we talked about the experiment management and the regression testing and the stress testing. But if you do it well, right, so you built your system before you deploy, you tested it well, so now you put it into production, you need evaluations again. Just this time, these evaluations will be online and they will be focused on the quality of experience that the users are getting in production. So basically, you may want to know, are the users getting good experience? Are the answers correct now when you actually deal with real user inputs? Maybe what type of topics the user is coming from. It can be a bit more analytical. So you need online evaluations. And last but not least, after your system is in production and you need to change something. So for example, you may be updating the prompt, trying different models, maybe fixing a bug or specific behavior that you observe. You also need regression testing, which is a familiar term for anyone who is working in software development. But this time we're talking about regression testing the quality of the LLM outputs. So basically, you need to make sure that after you make a change, you don't break some other behavior. Maybe suddenly your LLM starts becoming more vulnerable against adversarial prompts after you change something that was not intended to affect this. So you also need testing over and over again. So as you can imagine, there are different workflows that are covering all this. This is all evals, but you might implement them differently and run them in different setups. Here's one way to structure it. So if you try to divide all these or group all these into two parts, there are offline evals and online evals. So all the regression testing, experiments, and adversarial testing can be done offline, meaning that you can just run them as a script in your notebook, scheduled in some CI/CD flow and so on. But this happens offline. In online setups, you would run this as the users are getting the outputs, or maybe with a short delay. So actually, this requires different approaches, not just in terms of how you implement it from the system design standpoint, but also in terms of the evaluation methods that you'll be using. When you're running offline evals, you can actually run offline or ground truth-based or reference-based evaluations. They're sometimes called differently, but the general idea is that you can actually create a set of test inputs with known test outputs that you will be checking against to make sure that your system gives reasonable responses, the ones that you were expecting it to give. And with online evaluations, obviously, you don't have the luxury of having the right answers in advance. So you need some ways to evaluate the outputs as they're being generated. And there are different methods that can fit into each of these workflows. So now let's talk a little bit about the methods and the specific implementations. The first question is to answer what is the criteria that you're evaluating? Because of course, we're talking about very different systems. You might have a chatbot, you might have an agent, you might have a summarization tool. So the definition of quality can actually be very different. And depending on the setup, it can be, are the answers correct? Are the responses safe? Does the LLM call correct tools within your agentic setup and so on? You can, of course, try to think this top down when you're designing your system. You can come up with some expected quality criteria. But in reality, in most cases, you first need to interact with your systems to actually observe the type of errors that you get and the type of issues you see to prioritize what you want to evaluate. So for example, you might encounter a specific failure mode, like maybe the LLM gives absolutely unhelpful responses, and then you try to fix it with a prompt, and you need a way to evaluate if actually responses are becoming helpful. Or maybe it will not follow the expected structure of the output and so on. So you can actually first look what you see, and then you understand what type of things that you might need to evaluate and implement evaluators for it. And because the first step is usually looking at the data yourself and testing it out, the first evaluation approach is also quite manual. And there is absolutely nothing wrong with that. Actually, that's where you should start. You should look at the outputs you get and manually label them if they're good, if they're bad, and ideally comment also what specifically is wrong with that. In many scenarios, you actually need to involve domain experts here because you might be building a tool which is, I don't know, maybe a legal support tool or something like this. So you actually need to understand the domain to be able to assess what type of outputs you're getting. Of course, this is ideal. You might want to get this type of experts, you might want to label them, but it does not scale. For example, you are running experiments, you cannot ask your experts to relabel the outputs at every call, right? It's actually quite tedious. So the next step is to try to design these automated evaluations. And because we're talking here about offline evals, the first step is to design ground truth data sets where you predefine the expected answers to the set of questions that you're sending, and then you figure out the ways to compare if the new responses that you get are matching the responses that you expected to get. Depending on the scenario, it can look differently, and actually this pretty much resembles the classic machine learning evaluation approaches. And for example, if you're solving a task like classification, which can still be done with LLMs, you know very well what you can do here. So for example, if you want to classify the support tickets into topics, you know the expected topic for a bunch of test inputs, and then you can just compare how many classifications you're getting right. For many other tasks, you can do exactly the same, like if you're doing information extraction, if you're doing retrieval. And this actually does not apply only to these constrained predictive tasks. Sometimes it can be a part of a bigger, more complex flow. So for example, if you're building an AI agent, maybe your first step, and it's quite usual so, is to classify the user input and to understand to which route to send it, or maybe which tool to call, or maybe which prompt to apply based on the user intent. So actually that's a classification task, and you can solve it exactly as we described. So you define a set of expected queries about possible correct classes, and then you check if the LLM is actually predicting the same thing. But of course, it gets more interesting when the tasks are generative, right? So when the outputs are open-ended and the LLM not just returns one class or one number or one answer, but rather generates the whole text. Maybe it's like a chatbot answer, maybe it's a summarization tool. You can still apply this to an extent, but in this case, the matching will be much more difficult because, for example, if you're matching expected summary against the summary that you are getting, you cannot check for exact match, right? It can be worded slightly differently. But you can still apply some interesting methods to, for example, verify that the summary still has all the important points that you wanted it to have to make sure that the LLM behaves as expected. And of course, it all starts with test data sets. And whenever I say it, people usually say like, yeah, but we don't have the data, right? We're using an LLM, the model is already there. And the reality is that you still need to design this test data set. So in many cases, you can actually find this test data somewhere in the company. Maybe if you're automating a customer support chatbot, you can actually go and look at the past conversations with the users with the chatbots and then curate some of the questions and answers you get. Sometimes you can just write them yourself using your domain expertise, and you can focus on edge cases, on specific things that you know the LLM can get wrong. So you actually design like more tricky scenarios, and then you test how well it accounts, for example, for specifics of some geography or any kind of questions that may include some tricky part, right? So the LLM has to account for something to answer it correctly. In some cases, you can actually use public benchmarks. In this case, we're talking about not the benchmark itself that reports the performance, but rather the data set that is used for testing. So for example, if you're evaluating your LLMs for safety, you can actually use some of the public safety benchmarks, which have all types of questions like, for example, do not answer, all types of questions that your LLM should not answer, and then you can use it for your own chatbot. And last but not least, you can actually generate synthetic data. It's basically an aid. Instead of you writing the questions, you can ask LLM to generate the inputs or questions using certain formula or setup or expected behaviors, and then review them manually. And actually, we have implemented a bunch of workflows for this in evidently open source. So for example, you can define a user persona, the expected behavior, and then maybe generate a bunch of questions that the users can come up with, assuming, for example, that you are a customer support chatbot of a company called Evidently AI, and your users are data scientists that might be interested in something. So this is the data sets, right? So if we're talking about the ground truth-based evaluations, the most important part is the data set. And on top of it, well, we also need the evaluator. I'm going to talk about this a bit later. And the last one in types of evaluations, right? Beyond the manual evals and the ground truth-based evals are the open-ended evaluations which you can run in production. In this case, we basically need ways to automate the same labeling as we did manually, right? Using different automated methods. There are a bunch of them. I'm going to comment a bit more on LLM as a judge, which is one of the most applicable ones, but not only. So there are actually a few other evaluation methods that you can apply in this scenario. Let's talk about the methods. This is a very convoluted slide, and if you're interested, we actually have a whole course about LLM evaluations and a guide. We can drop a few links later. But the general idea is that if we're talking about reference-based evaluations, and we design this test data sets with expected answers, for all types of predictive problems, there are known metrics like for classification, regression, ranking, and so on. If we're dealing with things like summaries, there are known metrics from NLP, which are like rouge or blue. But in this case, we are basically looking at the overlap in words or word sequences between the two texts, which is sometimes helpful, but not always, because in many cases, we're interested in semantic difference or semantic similarity rather than just pure word overlap. But this is when we have the expected answers. And when we don't have expected answers and we're just looking at the outputs as they're being generated, there are also a few things that we can look at. For example, we can just evaluate at least text statistics, which is very useful, at least like text length. It tells you something, or maybe proportion of special symbols or the language of the response and so on. We can also use predictive machine learning models. For example, you can score the sentiment of the response or the toxicity of response and so on. You can also look for presence of specific words. Like, for example, you might have product names or competitor names, and you can just check how often they appear. And as you can imagine, there's like a big elephant in the room in the middle of the slide, which is LLM as a judge, which is actually one of the more versatile evaluation methods. You can use it both for reference-based and for reference-free evals. And now I'm going to talk about how to apply it. So the idea behind LLM as a judge is to use LLM to evaluate the LLM outputs. And here we are talking about essentially prompting an LLM with what we can call an evaluation prompt, which instructs the LLM to look at the outputs and assess it in a certain way and return a specific judgment based on what it has seen. I want to highlight that LLM as a judge is not a metric, it's a method. So for example, even if we talk about something like evaluating faithfulness, there is no official faithfulness metric or groundedness or anything like this. Every time you're writing the prompt, just sometimes you're using someone else's prompt. And the quality of the methods and the quality of the results actually depends a lot on the model you use, on the prompt you use, and how well you understand your own criteria, because it will vary depending on the use case, complexity of the data, context window, and so on. So basically, I think a very good way to think about LLM judging is it's a way to automate human labeling. And if you ever worked at any labeling project, you know that even if you were to instruct humans to label something or agree on something, it actually requires some work. So here we are basically doing the same, a bit faster and with LLMs. I know a lot of people are very skeptical when they hear it at first, because it sounds like almost like LLM is grading its own homework. But the idea behind this approach is that your main LLM product is actually doing something very complex. You might have a system prompt, which I've seen sometimes like a couple of pages, right, which instructs LLM on every possible action, on what it should do, how to process the user outputs, and so on. And it can get complicated, right? So that's why we get errors, because the system prompt is not perfect and the behavior can vary and so on. But when we talk about LLM judges, we're actually solving a very narrow task. And what we do, we're only passing the generated output in most cases. Sometimes we also pass the inputs. And we ask the LLM to make a very specific assessment. Like, for example, is this output polite or not? When you look at this, it doesn't sound too complicated, right? It's probably LLM is actually very good in assessing some subjective qualities, because it's already seen a lot of language and it can understand concepts like, well, not understand, but very nicely mimic concepts like politeness or conciseness or usefulness, or just assess if the response has specific properties, like does it contain a denial or something like this. So here is the idea, right? The judge is actually solving a simpler task, which is just looking at the output and evaluating specific property of it. And there are different types of judges. At the very least, there are the offline and online judges. And the offline judges can work exactly the same as this matching that we discussed. Just in this case, you're showing the two responses, the expected response and the response you get. And you ask the LLM to make the assessment if they actually match. So this is basically a semantic assessment of the match between two responses. And then there are also direct scoring of responses when you don't have the reference, but you just look at the responses you get, and, well, you evaluate specific property based on whatever you want to evaluate. This is actually very universal, right? So you can scale it to many other applications. So here's an example. If we talk about offline evaluations of correctness, you can provide your golden answer. Maybe like this is the chatbot response. Then you would generate the new answer using your LLM. You pass both to the LLM judge, and you basically ask to define if they're matching or not. And as you can imagine, it already has some subjectivity here, right? Because the answer can be longer or shorter. It can include specific details or not. You might actually want to instruct LLM to judge correctness on something very specific, like, for example, only look for contradictions, or maybe you would consider any omission to be incorrect. So actually, it's very useful that with LLMs, you can get so granular. And here's an example of output. Of course, it's like a toy example, but just to illustrate the idea. So we have here a question, like, why do we have seasons? We have a target response from LLM. Then we have the response that we actually got. And then we actually have two different judges. So one is looking at correctness semantically, right? So to check that there is no contradiction to the expected answer. And another judge is looking at the style match. Like, is the LLM using the same style, for example, to make sure that there is no actual change in like how it uses the words, how long the response is, and so on. Now, if you talk about direct scoring, I think I already explained the idea. It can be pretty much anything. You can ask, like, does the response contain personal information? Is the tone professional? Does it follow the format? And so on. And this is the method that you can use both offline. So not for all offline evaluations, you actually need ground truth, but most amazingly, you can use it online, right? So you can score the responses as you get during your real usage, and then pretty much evaluate if they're good or not. You can also pass sometimes additional context. And here by context, I mean that you're not just passing the response, but for example, you can pass the context that was retrieved for your RAG answer, or maybe you can pass the question that the user asked. And this way you can make the judgment looking at both pieces. Like, for example, you can ask, is the answer relevant to the question the user asked, by passing both the question and the answer. And last but not least, this LLM judging actually works on the level of session. So in this case, by session, I mean, for example, the whole transcript of the interaction between the user and the chatbot. Like, imagine you had like a customer support query, and then the user exchanged a bunch of messages with the chatbot. You can actually pass this whole transcript, as long as it fits in the context window of your LLM judge, and ask it to assess specific properties. Like, the most easy way here is like to focus on session success. Or maybe you can just look at the sessions that you might need to flag for human review based on presence of certain issues like user frustrations or repetitions, something like this. So this is a very good way. Instead of you reading the logs, you can pretty much ask LLM to read the logs and flag specific types of conversations that happened. So let's talk a little bit about how to create LLM judge. The idea behind this is a little bit cumbersome. So you actually need to evaluate your judge too, right? Because you cannot just trust the thing that you write without verifying it matches against your labels. So we have here like a small prompt engineering project where you first start with your own labels and then you try to use LLM Judge to replicate these labels. Let me illustrate it on an example. So we had here a toy use case where you want to assess the quality of code reviews. In this case, by code reviews, I don't mean the actual code, but rather the message that is given to the user as a commentary to his code generation. And first, the ideal way to create a judge is to be the judge yourself. And for example, we can ask a human to label the responses as good or bad, and then maybe clarify why it's good or not good, right? So that's what you can see here. This is something that can be human generated. You can maybe go like around 50 examples or something. Then you need to write the prompt. So you actually need to express these criteria in a way that you're going to be using for LLM Judge. Here I'm using a template that we have inside Evidently open source library, which basically includes some boilerplate things that you don't need to write, like returning the answers JSON and so on. So you only need to write the criteria. And here is the criteria that I wrote. The fun part is actually you can use LLM here to generate the prompts too by passing a data set with labels. So you can see it's like a lot of different ways, but of course you can also write it manually. And then you send these prompts to the LLM, you collect the outputs, and you compare the outputs you get against your human labels. So here you can see the resulting judge, which is pretty good. So it aligns with the human labels. And you can actually see that we just replicated the same thing that the human did, right? So we have the expert label, and then we have the LLM judge labeled, and the LLM is also providing the reasoning. So this is very useful if you want to align and understand what's going on. Now, a few tips about writing the prompts. I think generally the same, if you're building LLM products, you know what the prompt engineering is, and generally the same things here apply. So I would rather focus on like more nuanced things. So the first thing is you need to treat it like you're given a task to an intern who doesn't have any context, right? So even if you say about like evaluating if the answer is polite or not, define polite, right? So there are different cultural contexts. There are different scenarios. Maybe you would expect certain behaviors and so on. Second is to keep it simple and focus on a few classes, or ideally even binary classes. I know sometimes it's very tempting to evaluate something like politeness on a scale of 0 to 100, but in reality, if you as a human cannot do this without like very clear grading, LLM will not do it either, right? So if you have several classes, you actually need to describe every class and how it differs from another. You should also try to focus on individual criteria. So if things get too complex, don't put it all into the good bad labels. I mean, it doesn't matter how you call in many cases, but if you have like separate discernible criteria, just write several judges. You don't need to push it all at once. And ideally, you should also provide reasoning. In this case, it's not just because it's very useful for us as a human readers when we review the results, but also asking for reasoning actually improves the quality of the final LLM label because it basically leads the response to be generated from the previous reasoning. Evidently, we've actually implemented a bunch of templates for multi-class and for binary judges, so you can check them out too. And one more thing, it's a fun part to consider, is you can actually use a thing that is called LLM juries. I think in many scenarios it's more fun rather than like a recommended approach, but it can be helpful sometimes to bootstrap your own criteria. Or in some scenarios, you can actually do this. It's kind of like a voting approach when you ask different LLMs to evaluate the same thing, and then you decide how you can combine the results. So for example, you can either pass an answer only if all LLMs agree, or maybe if like a majority agree or something like this, depending on how you design the use case. And I think here it's a very interesting illustration, probably not very readable, but if you want, there is a blog linked there. So for example, I generated a bunch of emails, and then I asked LLMs to evaluate if the generated email is appropriate for a US workplace communication. It already assumes something, right? So that LLMs already seen a lot of different workplace communications, so they can make this judgment. And you can see here I used Anthropic, OpenAI, and Gemini. And actually, sometimes they disagreed. Like, for example, the use of emoji inside communication, or something that was like too harsh was seen like appropriate or inappropriate by different LLMs. So it can be a useful way to surface these disagreements and maybe to clarify your own criteria, because you'll understand what the edge cases are. Very briefly about more complex systems. I think the TLDR on this, what I was describing, was still within the like input-output type of thing. is that the same approaches apply, just they get more complex, right? So if you have an agentic system, it's more complex than just a single email generation. Emeli made an awesome presentation at PyData, and I just encourage you to check it out, specifically about testing the AI agents. But I'm going to share like a very TLDR version of that. When you're testing your AI agents on a kind of complex systems offline, you can first break it down into individual testable components. Like, for example, you can focus on tool choice correctness. So you can focus on correctness of retrieval individually, separately from the overall success. And of course, this requires the same thing that we discussed, where you define the expected inputs and possible outputs, and then you check if the expected outputs match what you get. So for example, for the testing of tool choice, you can define different queries that maybe could match to two different tools, right? And then you would clarify if the LM is actually choosing correctly. Another example I've already mentioned was classifying intent, or sometimes still testing the first response quality. So yes, your chatbot can answer along the very complex session, but you can still test if the first answer that gives you is correct. So it can still be useful to understand if there are any issues there. And the second approach is where you test the complete scenario, right? So instead of breaking it down, you basically replay the whole session and try to verify if the final response or answer or result that you get matches the expected. You can do this manually, but sometimes you can also automate it essentially as an end-to-end testing. That's the more expensive way, so probably you might want to focus on the most critical business scenarios and so on. Another example of what you can do if you're running on the whole session evaluation is you can look at the correctness of the trajectory that the agent did to make sure that actually sequentially call the correct tools and so on to make sure that it follows the behavior it wants you to. And if we talk about online evals, again, the same thing applies. If you have the complex agent or a chatbot, you can look at the whole session and evaluate the results of the whole sessions, or sometimes you can extract specific components of it, like retrieval, and you can still evaluate the relevance of retrieved answers, for example, within the context of online communication using LLM as a retrieval judge. Some takeaways before we go into the demonstration is, first, I want to say that evaluations require an investment. As you can imagine, I was describing this for half an hour, and it will take you, well, a few hours to even understand what you need to evaluate within your product of just looking at the data. And probably the more interesting part here is who is going to own it in your organization. In some scenarios, these are developers because they understand the domain. In some cases, it's product people. Sometimes you need to involve domain experts and so on, but someone has to own it, to design this test data set, to update them, to write the simulators and so on. If no one does it, well, no one evaluates it, right? Where you want to get in the end is you still need the data, right? So you need to not just own these evaluations, you actually need to prepare the data. Even if we are no longer training the models here, we still need it for testing. And ideally, the scenario where you want to find yourself after you work on the product is that you have a bunch of different test data sets, which are organized by scenario, by type of questions, by any kind of like meaningful behaviors or maybe edge cases. And you need the evaluators that are matching the scenarios, right? And you're going to have many of them, and you will update them based on what you see in production, or maybe new type of errors you see, or new types of bugs you fix, and so on. So it's going to be a continuous living data set. And one more thing I want to highlight, I think I tried to make my point with the LLM judge idea, is that automated evaluations are there to scale your human judgment. So before you actually implement automated evaluations, you need to look at the outputs and be the judge yourself. You cannot just outsource product thinking to an LLM without looking at the outputs you get and understanding what's good and bad. And last but not least, start somewhere. I know it can be overwhelming, but you can always write the first test case, the first scenario, and first judge and see how it works. So that's the idea, and then you'll build upon this if you already have a place. Maybe first you're going to have like 10 edge cases, and very soon you'll find yourself with 100. So I'm going to take a pause now and give the controls to Emeli to actually show us how this can work in real life.
Lovely, thank you so much. So let me quickly move us to the code part of the demo, and we're gonna get some fun with evaluations. But before we proceed to that, I want to quickly remind you that I do work locally inside of my virtual environment. So if you're going to do something similar, please do use it as well. Conda environment, Python environment, whatever you prefer, because we're going to use quite a lot of different libraries with dependencies. So let's prefer to be safe here. instead of like, yeah,
So
having,
I wanted to ask, so do you want to share the notebook?
yeah, I think I can share a link to the repo. Does it work?
Yeah, it would be cool. It would be perfect.
Yes, so let me just put it here on the chat. Yeah, just posted that.
Yeah, thank you.
Yeah, so now I believe you can follow along with us if you prefer, so or just do it after the recording. But yeah, coming back to the example, I'm doing it locally. So I have all my API keys for evidently for OpenAI already is the variables, environment variables, and I'm not going to show anything, but just be sure it's presented all there. So yeah, let me quickly start from the problem statement. I'm going to ask LLM to help me to generate some tweets, nice posts, so I can possibly share it on some social media and promote evidently, maybe, right? But as an engineer, I'm not really good at writing. And actually, I believe that this is something can be outsourced to the model. So yeah, but I definitely can come up with some nice topics like testing and AI engineering is super important, or maybe something related to CI/CD. So here is my topics I would like to discuss inside of some tweets or posts. So yeah, that I'm going to use as the input for my LLM, and I'll ask to write for me very nice, positive, engaging tweets so that I can post it later if Elena agrees and approves that. Well, yeah, to do that, I would need to create my OpenAI client. And for doing some tracing and evaluation, as discussed, which is quite essential to generate nice content or solve any other task with help of large language models, we are going to do some evaluations there. So I import quite a lot of things from Evidently, and I'm going to comment on them as we reach them in our example. And also I'm going to use some tracing. So we import a couple of things from Tracely. Both are open source, so it's comparably easy to start working with them. Also, I'm going to be saving the results of my work at Evidently Cloud so that I can share it with Elena, who actually knows much better about marketing and nice tweets as I do, so that she can approve and see what's going on there. Yep. Then it's happy. Okay, so I'm going to generate a project. For doing that, I need to have my organization ID, which you can basically derive from the cloud as soon as you register yourself here. So I'm doing it in our shared organization, and I have an ID already. And yeah, before I even start any evaluations, I do prefer to unit tracing so that I'm 100% sure that nothing kind of leaves behind and everything is tracked down. So here is my tracing. This is called like content generation basics so that I can later distinguish between different traces. And after I do that, I have some IDs, so it might be useful to print it out if I'm going to use it later to store some information there. So yeah, now I have all the preparatory job done and I can move to the Twitter generation. And I can start from the pretty straightforward instructions. Like maybe I omit the whole system prompt. And yeah, here I'm using the new API, the responses one. But if you prefer to use completion or chat completion, that's going to be fine as well. That's a very like short function. In this case, I use topic to generate a tweet on top of that, a model. And in my case, there is no system instructions particularly, so it's just an empty because I want to start from something really straightforward. And my input is going to be write a paragraph about the topic. Super simple, but let's see, maybe that's already enough to have a good post. As you can see, I covered my function by a decorator, which is called trace event. And this is pretty much similar to many, I would say, tracing tools which you can use. So basically, I'm just telling that I want to trace all the input and outputs variable from my function. Press lightweight code, I believe. And in order to generate some inputs, I'm just going to create a list of the tweets. So basically, I asked LLM to generate a tweet for every single topic, right? And then I will be able to analyze that, read one by one, or maybe create some better ways to see what's going on there. While it's happening, we can quickly go and see what is going on with our project. Yeah, and here it is. I just located by the name. And if I go to tracing, here it is. I will be able to see that here's my traces. And probably if I just hit the view button, I will be able to see all like tweets right there. So you can either read it from here. So we have quite a lot of information about the like result of the generation and other parameters, right? Like topic, model, instructions, or we can go back to our Jupyter notebook and proceed with the analysis right here. It really depends on how you prefer to work, but yeah, you can see that there are quite a lot of text, and if I would do some manual reading and evaluating, it would take quite a lot of my time, especially taking into account that I'm not like a professional marketing specialist or anything similar to that. So yeah, the good idea would be to maybe do some of automated evaluations, which was described by Elena before. For doing that, I would create my data set. Basically, I'm just loading it from traces. And I prefer to have it as the data frame. So it has quite a lot of information which was traced down by Tracely, including the topic, model, instructions, and the outputs, and the timestamp, of course. So maybe something here might be quite useful later if you want to do some experiment analysis and maybe elaborate on the dependency between the quality of your tweets and the model or provider or system instructions. So yeah, I do really prefer to trace everything. Now let's start our evaluations because we already have a data set. In this case, I would start from something quite short and brief. I mean, if I'm going to post it somewhere, it's better to understand the length of our tweets and also the sentiment, because I do prefer to keep it quite positive, right? Or even like very positive. So let's create some descriptors. Basically, the descriptor, it's just a statistic, a descriptive one. This is why it's called descriptor, which helped me to evaluate some properties of my text. In this case, we are evaluating tweets. Let me just add those descriptors to our data set. And if I browse a data set as the pandas data frame, I will be able to see that now I have two additional columns, which are length and sentiment, exactly what I asked to add to my data set. And though I can analyze that one by one, maybe do some filtering, or I can proceed with the report because it helps me to kind of aggregate all statistics across my data set and maybe see it visually or in any other format I prefer to. In order to generate a report, I'm going to import report object from Evidently. And also here, I have an option to specify as many different metrics as I want on top of the data set to be calculated and visualized. In this case, I don't really want to keep it super brief, so I go to the preset, which is pre-selected combination of metrics to address specific problem. In this case, my problem is text analysis, so I'm going for a text analysis. That's a report. Now I need to run it on top of my data set, and also to be able to later easily navigate through my many reports. I made some text. So my model was GPT 3.5, and I called it simple evaluation. I can also show it right there in Jupyter Notebook so that we do not have to move anywhere from here. And my first statistics is length. So I can see minimal, max, and mean value, quite huge, right? So in terms of having it posted in the Twitter, it's not possible, I guess. And some distribution, right? So yeah, that's quite long paragraphs. And also sentiment, which is surprisingly good. I mean, well, it's very positive. I think the minimum value is equal to, oh yeah, it's 0.9, so it's very positive text. Lovely. This is the good start for our evaluations, but in this case, I kind of have like only a few tweets, and probably I would be able to analyze that all myself. I mean, by reading them one by one, but maybe if I had a bigger data set, I would need to evaluate like more things and maybe even test it against some thresholds. So let me quickly save the results of my analysis to the cloud so that I can share it with Elena, for instance, by like sharing this link so that she can directly see the same report as I seen in my Jupyter notebook without an ability to kind of run anything. Just go there and browse and give me some feedback. Hopefully positive, but not sure. Well, yeah, I'll ask at the very end whether we're going to publish anything or I need to do better. Well, yeah. Now let's add some more advanced evaluations to our data set. So I'm kind of going to follow an example with the LLM as judge. And actually the whole point of making some tweets or posting something is to kind of be positive and engaging so that people were happy by the maybe tweets and follow some call to actions or maybe try out your tool. So I'm trying to build the engaging posts. For doing that, I wanted to evaluate that automatically, and I came up with my own criteria of what is engaging or what is not. But well, to be crystal clear, LLM helped me to write this criteria, but I'm fully agree with that. So here is what I believe is an engaging tweet. So it's some emotions, humor, opinions, encouraging interactions, what's not. And there is what is a natural one, quite opposite, right? So here is my tweet quality LLM as a judge. And now when I do some descriptors, I'm going to edit as well. So together with my text and sentiment, text length and sentiment, I do also LLM evaluation. And here I say that I want to use this tweet quality template, which is effectively my LLM as a judge. Now, having all this implemented, I also think that I'd rather see not just the value for every single descriptor, but I have some expectations, and I do have. So in terms of text length, I Googled how long tweets can be, so it should be less than 280 symbols. Also for sentiment, I prefer to keep it like bigger, higher than 0.8. And when it comes to the engagement, posts, I want them all to be engaging, right? More is better. So this is how I can formulate that. So it's tests added to every single descriptor. LT stands for less than or equal. GT stands for greater than. EQ stands for equal. Let us do that and see what kind of report we can get. So we add those descriptors to our dataset and quickly preview our dataset so that we can see that now we have like more additional columns. Now we have not only statistics like sentiment and tweet quality and length, but also the binary results of our comparison of the statistics against some thresholds, like length against this threshold, sentiment, and the tweet quality. So we can do quite a lot of variations and summaries based on what we just calculated. I mean, like now we have like binary results of tests against every single row, but maybe we have some expectations to the whole data set. In this case, we can do even like better and formulate those statistics in terms of those comparisons, let's say, in terms of like the tests for our metrics. So now I'm going to again create a report. Before I had just text evals without any parameters, as you I guess remember. And now I said that now I want to add some tests to the whole data set. So I'm going to check the length across the whole column. I prefer that max length for my tweets should be like less than or equal to 280. So now it's not like a binary, like a row level check. That's the column level check. This is why I have the max here, because I need to figure out what statistics I'm going to use. Again, for sentiment, now I prefer that the minimal sentiment should be greater than, oh, I think it should be even like, yeah, something like that. So let's keep that even more positive. And yeah, I want all of my tweets to be engaging. So now let me reformulate the report. As I'm going to send it to evidently later. So I add some text to distinguish between that, and let us run the evaluations. So here we go. Now, as I have like row level tests, I have these evaluations which say that, well, my length test was failed for all my tweets. It's obviously quite long, but all tweets are positive, which is the great sign. And now, in terms of engaging, unfortunately, not even one, so nothing to post yet. You would need to do something about that. Also, those descriptive statistics are here as well, so that maybe you want to dig deeper and understand what exactly is going on there. In this case, you're able to basically scroll down and see all distributions and characteristics. And also I have here a second tab, which is called test. This is super nice, I guess, because all the tests we formulated here now present there. We have a wonderful summary here, and for every single test, like the maximum value of our length or minimum value of sentiment or unique value count for tweet quality, we can see that there's the check against the thresholds we passed to our tests. And yeah, I can, for instance, only check the failed one and ignore past one. So however you prefer to keep it. Well, yeah, that's quite a lot of information. So it's always good to save it for further analysis. And I'm going to include the dataset as well so that we can analyze not only metrics and test results, but also raw data. Carrying on. Now it's time to kind of do something about the tweets quality. And I believe that maybe if I use the better model or maybe come up with the better instructions, it gotta be better. So let me try to do that. So easily distinguish between different parameters of my generation process. It's kind of similar to, not really similar, but the idea is similar to some hyperparameter optimization or doing some experiments with traditional machine learning. But in this case, of course, I don't do any like cross validation, but I kind of try to create the nice data set and then compare metrics on top of this data set. So yeah, I do really need to separate those data and traces. This is why I create one more tracing. In this case, I call it kind of like content generation improved, hopefully, right? Here's my instructions. I'm trying to follow in like good tutorials on how one should write prompts. So I say that you're a chief editor with a lot of experience in technical writing, and well, yeah, a couple of things more so that I can potentially get engaging and to the point content for engineers. So I really did my best here. Now let us try to pass these instructions to our tweet generator function so that it can get better tweets. And also I'm increasing the kind of model. I'm moving from GPT 3.5 to GPT 4.0 mini. So I expect that it's supposed to be better. And yeah, if we quickly go to the cloud, so we can see that we do have both reports that we created, the simple one and LLM-powered one. It's all here. Very similar, and our trace is supposed to be here as well. So the basic one and the improved one, it's really easy to navigate. But yeah, coming back, let us load it and analyze it right there in Jupyter Notebook. So I already have all the descriptors and reports parameterized, so now it's super easy to rerun all the evaluations, but for a new data set. So I don't have to create any configurations. Again, I just reuse like the same descriptors. Now I'm going to generate the same report. So you can see that I reuse the same object, but I call method run on top of the new data set. And yeah, tags are practically the same, but the model version is updated. Yeah, here it is. That's how it looks like. Oh, well, it could worse. Literally, before I had like more positive tweets, but now it's even, oh my God, it's unlucky. Okay, I'm not even going to read that because I feel like, oh yeah, it's not going better. But for this type of cases, and evidently we also have this automated prompt optimization. So if you feel like it's quite hard to come up with the nice prompt yourself, maybe it's high time to generate the dataset, come up with the quality criteria, and ask LLM to kind of optimize the prompt wording for you so that it meets the criteria on top of your dataset. And that's what we are going to do now. So I import from evidently LLM optimization, prompt optimizer, and parameters. And what I'm going to do here is I'm just creating the run prompt function, which take as the parameter a prompt. I need that so that I can call the iterations over this function to pass here different parameters and see what is the quality of my key metric. In this case, the implementation is super naive. Basically, you would prefer to have here a bigger and better data set. But what I'm going to do here is just I need to output the list of text out of my function. So I just generate the tweets with this model, having my generation prompt as the parameter for instructions. And this is exactly what I'm going to optimize with our prompt optimization process. So this is the prompt I'm going to like iterate over and over to get the best possible results. Now, what to automate? Basically, first I need to create this optimizer object as help of prompt optimizer. I would call it tweet generation with gen example is the strategy feedback. So here I'm trying to set up the base prompt, and the base prompt would be super naive because I'm not even going to start with my one. My one was really successful. So I'm starting the instructions from like your tweet generator. Probably being chief editor with 10 years experience just doesn't work. So I will keep it short. And then I'm going to run optimizer in an async mode. And here I use my run prompt function as the parameter. And I need to come up with the scorer so that I can score my tweets generated with help of this run prompt and optimize the results of my evaluation. And luckily, I already have the LLM judge for engaging, and I'm going to use exactly that. So this tweet quality is exactly the LLM as a judge, which we created before to check whether our tweets are engaging or neutral. So yeah, some parameters like provider, model, ls, that's it. And let me try to run that so that you can see what is the result. What is happening behind the scene is that we start from our base prompt, we generate the tweets, then we pass those tweets to this scorer, it scores that, and check whether we have all the results with our target label. Our target label is engaging, our non-target is neutral. So it tries to optimize the number of engaging outputs. It tried with the base option. The score was not very promising, but we knew that kind of. So now it tries to rewrite the prompt, then score all the tweets again and again until it gets like the better quality. So yeah, probably it was super easy for our prompt optimization process. Let me print out what we got as the best prompt. Well, it's not even super long. So yeah, your tweet generator capable of creating engaging and interactive tweets. Well, good start, right? And that's what LLM suggests us is the better option of our prompt. Okay, lovely, let's try. I'm going to create one more tracing data set here, and I'm going to also kind of run the tweet generation, but now as the instruction, I use this optimizer best prompt so that I use the best possible system instructions for my generation process. And as soon as it's done, I'm going to also kind of run the same evaluation process so that we can create a report with all the tests, dataset level and the row level so that we can see what's going on. But remember, we optimized it only for being engaging, right? Nothing more. So at least I expect that the share of engaging tweets should be bigger, like higher. And I hope it's going to be positive in terms of sentiment. So let me quickly add that. I just add all the same descriptors and run the same report. So let us quickly preview. Yeah, again, all positive. And yeah, now everything is engaging. Well, I believe that's high time to kind of send it to the cloud, generate a link, and share it with Elena. Maybe she'll like something, and later we'll have a chance to post something to our social media. So let me stop here and check whether you have some comments or questions about the topic.
I think I can approve some of them
Yeah.
while we're waiting, Emeli. I took a peek.
Yeah.
Yeah. Thanks a lot, Emeli, Elena, for insightful lecture and great demo. Yeah, there is a number of questions. So
Should we just read them out? Because I think
yeah, it would be perfect.
I think I'll start from the first ones, which are probably asked during my session. So the first one was, how many cases, data set size, do we need to train LLM judge? I'm afraid many of the things that I'm going to be saying it depends. To train an LLM judge or to create an LLM judge, you need to comprehensively describe the possible space of your outputs, right? So that you don't exclude certain cases or criteria, right, that you might actually want to apply. Of course, it's never perfect. I think as a rule of thumb, I always try to go for like 30 to 50. It's not as scary as it seems. And ideally, if you pick it from the real outputs and you have good test data sets, it should already be comprehensive enough. And then, of course, you can add it later and improve your judge, right, by feeding the new outputs and manually correcting the labels. But I think 30 to 50 is like a safe choice, but it's not like a scientific answer.
Maybe I can quickly comment on that. We understood this question like how many examples should you have in your data sets to write a nice prompt for your judge, but we are not talking about retraining or like fine-tuning your judge like an LLM, right? It's going to be like very different in this case.
I think it's the same way asking like how many outputs do you need to read to actually be able to formulate your instruction to a human being, right? So it depends on the complexity and diversity of the task, but essentially that's what you're doing here. The next question was like, how much does LLM as judge approach depend on prompt? How to construct best prompt? Do we need to ask one more LLM about it? I think it was asked in the middle before I showed the LLM jury approach, but the reality is it does depend on the LLM a lot. I simplistically define them like, capable LLMs and not very capable ones. Like, for example, if you're using small open source models, you can ask it to judge simple things. Like, for example, looking for contradictions between short sentences, it will be doing well. But comparing large context to check for contradictions or something, of course, you need more capable LLM. And the prompt also has to be more or less specific depending on the task. So I'm afraid the answer is like, it depends on the complexity of the task. But I think the best place to start is not to choose the LLM, but rather to identify your criteria and type of outputs that you are dealing with. Because the reality can vary a lot. Like sometimes you really have like paragraphs of generated text, and sometimes you're comparing answers like, the capital of France is Paris versus Berlin, right? So you don't need the complex LLM. Or the criteria can be like sentiments of the text, which is honestly a very easy task for a LLM. You don't often need an LLM like Emeli showed for that. So it depends. I don't know, Emeli, do you have anything to add here? Like how much does it depend on the prompt? It depends. So then the next question was like, how often LLM judge contradict itself on rerun? Is it a good idea to run the same LLM multiple times? I think sometimes yes. In my experience, if you have like a longer prompt that actually spells out the details, it happens less. If you start with a very simplistic prompt, like is it correct or not? Is it good or not? This will happen more often. Of course, you should also try to limit the temperature of LLMs, right? So to make sure that there is less of these things happening. And what I also found helpful is that you include in your prompt an instruction which basically tells the LLM what to do if it's unsure. So you can say like err on the side of caution, and if there is like possible risk, say that it's incorrect. This way you will control the outputs better, right? Maybe at the like you get like better recall and like worse accuracy, but that depends on what you're doing. In many cases, when you want to surface bad outcomes for human review, that's actually a very good approach. But it does happen, and when you're testing your LLM judge prompt, like I showed, like evaluating it against labels, you can actually do it several times and then see that it actually stays coherent.
Yeah, and it's also the case of positional bias if you do some pairwise comparisons.
I quietly ignore this topic because honestly, I haven't found very useful use cases for pairwise comparison when you talk about production, right? You don't have two answers in production in most cases. But yes, there are many biases. There's like verbosity bias, positional bias, basically superficially long, competently sounding answers are rated higher than actually correct answers in many cases. That happens. But I think with a good prompt, you can overcome and with good use case. Okay. There's one more question. Is it possible that we overfit prompt judge for current model we are evaluating? I like this term, like overfitting. I think it does happen, especially if you do write your LLM judge prompt not the way Emeli did, but rather sometimes people put like specific examples, right at the prompt, if this input says that, if that input says that. So it actually becomes almost like you literally ask an LLM to memorize the rules, right? And it will not go outside that. So that does happen in terms of like overfitting the prompt. So we recommend to judge it like more generically. But talking about overfitting for a current model, I think prompt is always attached to the model. So yes, if you're switching the model, especially the model family, you would probably need to rewrite the prompt, at least slightly. Some models will be comparable, but still it's always best to test it for specific ones. I'm sorry if my answer sounds again like it depends and you should test it, but that's the reality of it. I don't know, Emeli, do you have anything to add about overfitting the prompt for the current model?
Emeli, so I guess when you work with LLM as a judge, you definitely need to evaluate the quality of this judge, or at least an alignment of the judge with your human experts, even if it's yourself, that's totally fine. And maybe in this case, you would need to read some labeling. I mean, to physically like see what is the output, how did you label it yourself, and how did you label it as LLM as a judge. And in this case, you kind of could overfit the LLM judge criteria by what you included in this data set, because you definitely cannot do it for like 100 of outputs, right? It's going to be kind of 5 to 10, I guess, but it's not a lot. And yeah, if you just check the quality of your LLM judge against small data set, you might overfit to this. And as soon as you generate a bigger data set, it might be not that perfect. So I would be more like worried about that and make sure that my validation data set is quite diverse to avoid this.
I wish we also have like the held out data set, but I know it's a bit too much to ask in most scenarios. We had a question also, how to choose the best one LLM as judge model for eval task. Can LLM's biases ruin eval? Yes and yes, so it can, especially if you're asking to judge something that is very not precise, right? So for example, like things like politeness or societal impact, or maybe is the answer is medically correct, right? So there is like no way to objectively know it, and LLMs can bias the outcome. But in terms how to use it, starts with some assumptions, just like you choose the LLM for your main product. Start some assumptions about the complexity of the task and the data that you're dealing with, and then test and compare. So as I already shared a few examples, if you're dealing with small text and relatively easy things, like for example, does this answer contain a denial? Or is this answer positive? Or did it say thank you, right? Probably a small LLM will do. If you're asking for actually very comprehensive reasoning over like a large corpus of text, often you can use LLM for evaluation that is more capable than the LLM that you're using in your product, right? Because it makes sense, it's still cheaper than humans. So it does depend on the type of task that you're using, and of course you can later compare. I can say like as an easy default, we tend to use GPT-4 Mini in many scenarios, but it's not like a universal, that's just like a cheaper model, which still makes sense, and it lacks the general knowledge about the world, but we don't really need this general knowledge for the evaluation task that we are dealing with. I think there is one more question is very similar, like if you don't have strong LLM to be a judge, is it possible to use your LLM or your previous version as a judge? Here we're not judging the LLM, right? So we're judging the product, and in a way, yes, you can use the same LLM that you use in your product because the prompt will be different. So absolutely, but it all boils down to actually testing it against the labels. So the whole story was about that. And I think one more question, which just probably was answered. In case of reference-based LLM as a judge evaluation, is it reliable to evaluate answers of strong LLM with more shallow LLM? Because we don't hear the task of the matching, right? So you're not asking it to generate the answer. It can actually sometimes be done by a much shallower LLM. It's true, but it depends mostly on the context size and on the type of judgment that you want to make. So for example, small mismatches in details, if they're important, you probably need like a better LLM. If you check for general contradiction, most likely a simpler, more shallow LLM will do. I think that was the questions that were asked during my type of presentation. So Emeli, we're now approaching yours.
Okay, let me follow up from here.
If you want, I can still read them.
Yeah, I think I just find the next one, but if I miss something, please to help with that. So yeah, I got a question. How can I try this awesome LLM? And I believe, Mike, you know how to try it out, but yeah, to share with everyone, that's an open source project. So if you say pip install evidently, it's all yours. And we do really appreciate the feedback on the topic. Then I have a question, is word with quality enough to have just binary classification? I guess it's all up to the designer of the system. So for me, I believe it was enough because it's either like engaging or not, but definitely we have like a template for multi-class classification, and you easily can add up more categories. It can be 3, 5, or how many you want, but make sure that you can describe every single category properly, and it's not kind of contradict, because we know that multi-class classification generally is more complex compared to binary ones, and you need to make sure that like even human expert can kind of differentiate between your labels. Next one. Yeah, what prompts are we using inside for prompt optimization? Well, we are open source, so it's kind of easy to locate. But generally, that's prompts which says that here is the data set, here is the criteria. Please rewrite the prompts to meet the criteria. I mean, I'm simplifying things, of course, like now, but it's all in the GitHub repo. Do you have integration with this spy library, or do you use your own optimizer? Currently, we do use our own optimizer, but it might be a good idea to do that later.
Maybe just to add as a comment, we do have a slightly different implementation, because in this case, we can actually accept the LLM judges as the optimization criteria, right? So the measurement of the outputs. And we also take in this free-form human feedback, which is an awesome way, for example, to create LLM as a judge, just like I was showing. So we kind of took a different approach, which allows to take these human comments inside the optimization, not just generated output. So I think it's quite complementary to what this API does. So you might want to check it out.
Yeah, so right now we have like a few ways how we can do the optimization, but we are going to increase the number of different strategies. So might be there are going to be some new updates, and also can I spoil the new blog which is going to be released soon or not? I don't know.
Like tomorrow, yeah. So it's going to describe this implementation.
So yeah, there will be much more details on the topic. Yeah, I'm trying to find like next question.
I can read it. Assuming I use OpenAI API, how much money should I expect to spend on evaluation and prompt optimization, like in this example?
In this case, it's fairly cheap because the input and outputs are like super small. So the cost is like less than the 10 cents, I believe, like for the whole evaluation. But it really depends on the model, whether you're using the reasoning model or the simple one, or even you might use your own self-hosted model for doing that. In case your model, I mean LLM, supports OpenAI API, you can use it in Evidently and do evaluation as help of this model. So it can be from 0 to maybe some sense if you have like a huge data set and the long inputs.
But that's actually one of the reasons why we default to 4 mini for the OpenAI, because we think it's very reasonably priced.
Yeah.
It's usually cents, all this.
Yeah, I think I got this next one. How can we validate that the prompt optimizer actually optimizes our prompt? Interesting. So yeah, I think the best way to do that is to kind of take a look at that at the result. I mean, to read through that. But also it makes sense to use this LLM and the judge approach in case if you're using judge criteria is the optimization criteria. But in case you optimize something like accuracy and your prompt is written to solve like classification problem or any other supervised problem, when you can use some loss function or quality function. In this case, I would go with the applying the new prompt to the preferably holdout data set. That's not what we had here during the demo, but generally that's what we do for machine learning models training, right? So to be like very practical here, I would split my data into these two parts. One I would use to optimize my prompt, and I would check the quality on the other prompt using the same quality metric.
I think I found the next question. I can read it. Looks like it was used the same LLM for LLM Judge and for its generation. Is this bias in this case? Does LLM Judge give better grade for itself? Thanks for the great session.
Oh, that's a very nice question. I guess that's very depend on the type of your generation. I mean, if it's very specific, and we know, for instance, that there are some benchmarks which says that some cloud-based models are better for code generation compared to OpenAI, right? And in this case, I mean, some previous models, I don't want to kind of somehow discriminate any providers. So I'm trying to be like very kind of reasonable here. But in case you know for sure that based on some benchmark, one LLM is better for some specific task, in this case, of course, there is the bias in terms of like choosing this provider and the specific model. But I believe that when it comes to generation of something and running LLM as a judge, we don't do it in the batch mode, right? I mean, we do not share any context. So I guess it shouldn't be like that. But there are a bunch of other biases which are definitely present. And in this case, we should be quite accurate in the formulation of our criteria, because there are a lot of things related to like professionally sound or grounded sounding criteria and outputs. So if it sounds good, it might be graded better, but in reality, factually speaking, it might be worse. So yeah, LLMs are biased, and we should be really careful about the criteria. But I believe the bias against the model itself is like smaller compared to all these known biases.
And I think absolutely, if you suspect that this might be the case based on your criteria and how you formulate it, it's no harm to use this jury approach. And you can actually use it like compare, for example, OpenAI and Gemini, and then call some Nebius hosted models like DeepSeek or something, and then compare the answers, absolutely. But in any of these approaches, we'd recommend to compare it against your human labels after all, because even if all models agree or disagree, you'd still need to make the judgment at least on a few examples to make like, is this tweet really engagement? Like, what is your definition of engaging as a person who wants to see these tweets, right? And then choose the model that actually aligns best with your understanding of this criteria.
Yeah, I would agree here 100%. And even if you like consider to somehow reduce your budget on the evaluations, you can still use jar of self-hosted models. That's going to be fine as well. Or again, let me just tell that Nebius has this free credits for anyone who is registered. Sorry for saying that if it's a secret, but yeah.
I think we just tested the $1 on DeepSeek.
Yeah.
There's one more question about drift, the favorite topic of all times.
Drift.
How does Evidently handle drift in LLM-generated text over time? And would you recommend adding embedding-based similarity metrics alongside the default text evals? I think there's actually two questions, because similarity metrics can be used in, for example, comparing the expected answer against the generated answer, and you can absolutely use them. We have this implemented in Evidently. But I think drift is an interesting topic, Emeli. What would you say about handling drift in LLM-generated text over time?
Well, yeah, that's my favorite topic, but yeah, I'll try to be as brief as possible. So in this case, when we talk about some overtime evaluations, I would go for monitoring rather than the comparison. I mean, the experimental evaluation. So I would maybe schedule the regular run over our traces, especially if you do have your application already deployed. So you have a chance to kind of trace everything and then run some evaluations like daily or hourly, depends on the amount of the data and the level of precision of the evaluation you want to have. But still, I would measure the drift by comparing some continuously batches of your outputs and plotting that as a dashboard. I didn't show it during the demo, but and evidently we do have like a drift evaluation built in, and also the dashboards, so that you can see how the drift score changing over time. And also you could easily include the data drift detection metric inside of your report, but in this case, you would need to have the solid basis to your comparison. So you would have to invest quite a lot of time into creating your reference data set, which is kind of a project itself, because it should be diverse. It's supposed to have quite a lot of examples. And if, for instance, for some reason you do have a seasonality, and it's might actually be the case. I mean, even for some assistant, maybe during the weekends, users ask about some more like fun stuff, but during the weekdays, they are more focused on the work, right? In this case, if you compare the drift between the Friday and the Saturday, that's going to be a drift. So yeah, this drift evaluation is kind of an art. You need to take into account a bunch of things, starting from the batch sizes to the seasonality potentially. But as soon as you are happy with the results on top of historical data, you could start validate it continuously and set up some alerts in case the drift is detected. So I would start from the reference data set and then a bit play around with the parameters so that you do not get a lot of false alerts.
I would maybe add to this that I would start with a question, like trying to not use the word drift, like what you are looking to answer. I know that sometimes people talk about drift because they did not fix, for example, the specific model tag that they're using, and then suddenly the underlying model is switched and behave differently, right? And there the problem is not drift per se, but rather you need like to make sure that you're using the same model, or if you're switching the model, if you regression test the inputs for the same behavior. And sometimes we're talking about identifying changes in the user inputs, right? Are the users using system differently? So maybe there are different ways to approach this. Like you can monitor topics and classify inputs by topic. So I would probably start with a also question that you want to answer, and then like reason about how you want to apply it. I think we had a couple of more quick questions if we still have 5 minutes. One was, how does evidently stack with something like OPIC? And in this case, I can answer it. OPIC would be a competitive product here. So they essentially solve similar tasks. I think they have fewer capabilities in terms of built-in evaluation. So this is like a huge part of Evidently. And because both tools are open source, you can technically use our evaluations, export the outputs as Python dictionary or JSON and send it anywhere else without using the pretty reports. So in this case, you could use both tools together. But if you're looking, for example, for tracing or logging experiments, you can actually use both. That would be just a choice of two different tools solving similar problem. And then we have a question, I guess, to you, Emeli. What temperature do you use for the LLM and LLM as a judge?
Well, we're pretty straightforward here. For LLM as a judge, we use the zero temperature to make it as stable and robust as possible. But for LLM itself, that's up to you, right? Because it was just an example, and you are the owner of your LLM-based function or class or project, right? So you can set any temperature you prefer to. It's kind of the parameter to play around with during your experiments and select the best one.
We have like a follow-up question. In what cases would you want the temperature to differ from 1? And I guess you almost answered now.
Yeah, in case I want to have my output as stable as possible so that I can rely on that, kind of trying to get some robust estimation. In this case, I would have it closer to 0.
Like LLM judge. That needs to say as stable as possible. So we're at the end of questions and we're almost at the end of time.
Yeah. Thanks a lot for this presentation and for answering questions. It was so cool to have you today. And thanks for everyone for being here, for asking your great questions. See you next time at the next Nebius Academy webinar.
Thank you for having us.
Thank you so much.
Thank you, everyone.
Yeah, thank you so much. Bye. Have a great
Bye-bye.
evening, morning, afternoon, night.
Wherever you are. Bye-bye.
Bye.